Geometry 10.3 Inscribed Angles. By the end of this lesson, you should be able to use inscribed angles to solve for missing measures. We first need to talk about what an inscribed angle is. And an inscribed angle is what you see here. It's an angle whose vertex lies on the circle. So angle DBC is an inscribed angle. We also have other special, features of inscribed angles. And this arc that's contained by the inscribed angle is called the intercepted arc. You can think about this like in terms of football and interception. You catch a pass, so you can think of this angle as catching this arc. We also have inscribed polygons. And an inscribed polygon is a polygon whose vertices are all on the circle. What we also know about inscribed polygons is that a circle that contains that inscribed polygon is called the circumscribed circle. Earlier in semester 1, we talked about a circumcenter, and that has to do with the circumscribed circle. But for the purpose of this unit, you just need to know that if a polygon has all of its vertices on a circle, it's considered to be an inscribed polygon, and the circle that contains it is a circumscribed circle. We have a few theorems that have to do with inscribed angles. And the first one we have is saying that if an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. So looking at this, if we were to say that this is, let's say, a 100-degree angle here, that would mean that this arc's measure would be 100 degrees. What this theorem is saying is then this inscribed angle is going to be half of this measure. So this inscribed angle will end up being 50 degrees. Our other theorem says that if you have two inscribed angles and they intercept the same arc, then they're going to be congruent. So here we have angle ACB, and ACB intercepts this arc AB. We also have this angle ADB. This one is also an inscribed angle, and it also intercepts the same arc. So what that means is whatever this arc's measure is, let's just say that it's going to end up being, let's say 90 this time. That would mean that we have two 45-degree angles, and that would mean those angles are congruent. So let's practice this a little bit. Here we're given either angle measures or arc measures, and we need to determine whatever angle or arc measure is being asked for. So here we're asked for find the measure of angle MNP. And MNP is an inscribed angle because its vertex is on the circle. And we know that based off of the first theorem that we talked about, that this intercepted arc is going to be twice as big as this inscribed angle, meaning that if this arc is 88 degrees, that the measure of angle MNP is going to have to be 44 degrees. Next, we have an inscribed angle, and this is asking for us to find the measure of major arc RVT. And similarly, we're going to use the same theorem, however, we're this time looking for the arc measure. And we know that this inscribed angle is half of the measure of the arc that it intercepts. So we can say the measure of arc RVT is going to be equal to 182 degrees. And last but not least, we have this third problem, and it's asking for us to find the measure of angle A. Now, angle A intercepts this arc BC. What we should also notice is that this angle BDC also intercepts this arc. So if I knew the measure of this arc, I could figure out the measure of the angle A. And we could figure out the measure of the arc because we have this other inscribed angle. Now, our theorem from before said that if they are intercepting the same arc, then they're going to have to be congruent. So we can go ahead and say that the measure of angle A has to be 38 degrees. We have a couple more theorems, and these have to do more so with inscribed polygons. The first one says that if you have a right triangle and it's inscribed in the circle, then the hypotenuse is the diameter of the circle. Also, the converse is true. So if one side of an inscribed triangle is the diameter of the circle, then this is a right triangle. So what this means, and we could take a look at this, we know that this diameter is going to cut the circle into two circles, and we know that that's a semicircle. Thinking about this, if I wanted to figure out what this arc's measure is, it's a semicircle, so it has to be 180 degrees. And using the theorem we just learned, we know that this inscribed angle has to be half as much as this intercepted arc, which means that this would have to be a right angle. So anytime you see a triangle inscribed in a circle with the diameter as one of its sides, it's a right triangle. Our other theorem also has to do with inscribed polygons. And this one says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So we will have to say that the measurement of angle D plus the measurement of angle F has to equal 180 degrees, and the measure of angle E plus the measure of angle G has to equal 180 degrees. And using the theorems that we had learned before, I'm going to show you how this is true. So angle D is going to end up having this intercepted arc. And if we look at angle F has this intercepted arc. Together, these two arcs make the whole entire circle. And if these angles have to be half as much as the arcs that they intercept, that means that they're going to have to add up to 180 degrees. So here's our last example, and this is asking for us to find the values of x and y. And using the last theorem that we just mentioned, we can set up a couple of equations in order to solve this. We know that if we have a quadrilateral inscribed in a polygon, these opposite angles have to be supplementary. So angle W and Y have to add up to 180 degrees, and angle Z and X have to add up to 180 degrees. And we can come up with two equations that show this. So we'll start out by saying 18y plus 126 is equal to 180 degrees. And then the other equation that we can say is 18x plus 72 is equal to 180 degrees. So here we'll subtract the 126 from both sides, and we'll have 18y is equal to 54. And then when we divide both sides by 18, we get that y is equal to 3. For x, we can subtract 72 from both sides, and we have 18x is equal to 108. And when we divide both sides by 18, we find that x will be equal to 6. And we have those values for x and y. That was our last example, so that means it's time for a joke. And this next joke is also one that's submitted by some of you. And this says, why did the Italian restaurant go out of business? Well, it went out of business because the owner passed away.